Hello, welcome to CAD in Beam, where we train civil and structural engineers. My name is Lucas Chacha and I'll be your instructor. In this tutorial, I'll be doing a recap on column orientation. So one of my subscribers asked me to just redo or do a fresh explanation and clarify a few things on column orientation, and here's what I've prepared that I'd like to teach you. So kindly feel most welcome, and this is a very brief tutorial. Kindly watch to the end. Without wasting my time, let's get started. So there are facts, or there are things that you'll have to understand or to consider when you're doing your column orientation. Always remember, the shorter part of the column is the breadth and the other one is the depth. The longer side is the depth. The breadth is always the width and is the one that should be perpendicular to the longer beam or the major axis of orientation. So just note this one: the longer side is always the depth of the column, while the shorter one is always the breadth. So, and in a second part here, you should know now that the axis which is perpendicular to the depth is considered as the major axis. So this is the major axis, the minor axis. Now, if you orient your column on this side, the major will be the one that is along the depth, that's aligned parallel to the depth. And just as here, you can see, as you can see here, we have the shorter, we have the minor and the major axis. Understand that the major axis will always be perpendicular to the depth. As you can see here, the major axis is perpendicular to this depth here. So note that down. And then the other aspect that you ought to understand is that the column should be oriented in such a way that the axis of bending is the major axis. So this is the axis of bending in this side. So to just have a better explanation on this, let's just look for an example that you are working on. So if, for instance, you have your columns, this 450 or 4.5 meters, and the other one is 4.5. So when it comes to moment or bending moment, the two moments will cancel, and then you will be left with this column here. So you arrange your column the shorter span so that it is perpendicular to the longer beam. This is how you arrange now your column, because of I'll just be revealing you how the bending moment will affect the column once you arrange it this way or once you arrange it the other way around. So let's go back to our PDF. So presumably, if you arrange your column, the first one is you arrange your column with the shorter span or with the shorter length here. So this is the length of resistance. Here we are looking to increase the length of resistance. You can see the figure, my first figure here. The length is just 5 inches. So you can see the length of resistance is smaller. So if the length of resistance of that moment is smaller, there will be a major bending moment. As you can see this diagram here, this is the bending moment. But if you arrange it on the other way around, and you ensure that you have a larger length of resistance, then you also reduce the amount of bending here. So if you take this diagram into our analysis softwares, for instance here, this was done in ETABS, you will see that this also was another illustration of that. In case you have 3 meters and then you have 7 meters and you have 3 meters here. So these are the columns, and this is the first beam, this is the second beam. So you arrange it in that manner so that the shorter side of the column will be perpendicular to the longer side of, or the side that is coming, it should be perpendicular to the side with the highest moment or with the highest bending moment. So you can see this one here, we have the longest bending moment, or not the long but the largest bending moment. So that's why it is arranged perpendicular to this shorter side of the column. So let's go on. Once you do analysis of these beams in a software, now you have loaded your first beam here. You can see how you have arranged this one, and you can see also how you have oriented this one. So once you run this one in analysis, this is what you will get. You realize that for our first column, if you can't see this 44, I want just to zoom it so that you see it very well. So for our first diagram, we have 44 as the bending moment, while the other one we only have 28. So meaning that we'll need more reinforcement to counter this bending moment. Hence, more reinforcement means more cost, and also if you use same reinforcement, this one is likely to fail as opposed to this one, which is resisting a lesser moment of 28 kilonewton. So it's almost actually twice. So just orienting columns correctly, it can improve the structural integrity of building. At the same time, it will save on cost. So as a structural engineer, you should ensure that before you do anything, your arrangement or your orientation of columns are done properly, so that you reduce the bending moment, will subsequently will make your building more structurally more stable or structurally sound, and also save on a less amount of cost, and also don't you don't over reinforce, so that you achieve structural stability. So this is why I'm insisting on the issue of column orientation. So I believe this point is now well taken, and now all the work that we are talking about orienting columns just to ultimately want to reduce the bending moment. I believe this one will be visible. Yes, all what we want to do, want to reduce this bending moment here, as you can see. So thank you for listening, and let's continue subscribing. So you can see I did my orientation here, my columns, all of them are okay. I believe